So when it comes to process design and microbial control, we usually have process flow diagrams. We've taken samples. We know what our environment looks like. We have established critical quality attributes, in-process controls, microbiological attributes. We have bioburden, endotoxin. We know all of this. We know what our particulate attributes are, defined hold times that we can keep product before we go on to the next step, whether it's aseptically filled or terminally sterilized. And we have process validations to show that we can, reproduce the product over and over and over again under the same set of conditions that are defined here. So we have a lot when it comes to process design and microbial control. With facilities and utilities, we've always got the air pressure control following the ISO system. We have water systems, water for injection, distilled water, whatever is feeding into your laboratory as well as your manufacturing site. You've got controls over that. You've already done a cleanability assessment. How easy is the equipment to clean? How easy is the facility to clean? Is there any degradation of the walls, the floors, the seams, the material flow? How do I bring it into my clean room? How do I take it out? How do the personnel come into the clean room? And what do I do with the waste? And the validation of that system. So we have a lot with facilities and utilities. When it comes to raw materials, we have the incoming specifications. We get a receipt, we get a certificate of analysis, we quarantine the material until it's been sampled and tested and approved and released by the quality unit. And we, hopefully, all of you have a supplier quality agreement for your raw materials so that you know that your supplier is reliable and is going to give you consistent product, consistent materials over and over. So we have raw materials, we have environmental controls and validation, and that's environmental controls for the areas that we're going to work so that we don't contaminate the product. So we do particulate monitoring, environmental monitoring, media fills to represent when you're aseptically filling, right? To represent that you don't contaminate the product, you're going to use media. Smoke studies, both dynamic and static, when you're in operation and when you're not in operation, so that you can see what the airflow, that you still have control and your HEPA filters are still working and the air pressure is right and the movements, and you're doing nothing in there to contaminate product. Temperature and humidity are monitored, and if anything goes wrong, typically you have a recovery plan. Personnel training and qualification. Well, any organization involved with the filling of aseptic or parenteral drugs has a gowning qualification and a requalification. You don't just qualify once, but you periodically have to requalify. And there's a disqualification if you don't if you get hits while you've been gowning, you may be disqualified for a time until you can pass a requalification. Personal hygiene is important. We all have criteria around that. Clean room practice, how you move, how fast you move, and then of course production microbial monitoring, monitoring your gowns, your gloves, and settling plates. All of that goes into supporting the personnel and the qualification of the personnel and how they manufacture the product. Then we have equipment validation. Of course, all the equipment we work on has to be validated, designed appropriately for its use. We have to be able to clean it so there's no cross-contamination. And we do oftentimes preventive maintenance, right? And there's always change parts available. So we know what's likely to break down, what we need to fix, how we need to prevent when things are going to degrade. You know, we don't wait until the HEPA filters degrade before we actually go and change them. Well, it's the same usually with the glove. Those gloves are replaced periodically before you wait until the glove disintegrates and you're contaminating the product. And then the container closure system, certainly after we've manufactured the product and put it all together, we don't want anything being able to infiltrate in through the container closure system. So we do a lot of study on that, make sure there's container closure integrity. It maintains a sealed environment. We do extractable, leachable, so we know what's coming from the glass or the stopper or the bottle. Certainly sensitivity to light, moisture, heat, and cold are all involved in the container closure aspects of contamination, containment control. And overall, we have the quality systems where we've got the trending, the metrics, the deviations, the CAPAs, everything to help us investigate when things go wrong, why it goes wrong, when we might have to reject product, under what conditions we would reject the product, how we would validate, change the system, quality control, the laboratory is under their quality agreements. Do we have any risk management, the change control for any changes, plan, do, check, act. If we're going to make a change based on a CAPA, based on an investigation, we're going to run our plan, do, check, act model to drive for continuous improvement.